Hey folks, yeah, we'll address that in a second. If you know what that is already just by the sight of it, I don't have to convince you to not click off this video because it's pretty cool. If you don't know me, I'm Mitch and I make experimental musical instruments and silly machines under the name Hack, and I also work at This Museum Is Not Obsolete, where we showcase all kinds of amazing creative and industrial technologies from the last 100 years. You may have guessed from my surroundings. I'll give you a quick little look around the room. Cool room, by the way. I mean, least of all, the furniture game is tip top. I'm on a field trip, we could say, up in Leicester. I'm at R10 Electronic Media Studio, an amazing creative and educational space. Just looking around the room, you can see a collection of some pretty inspirational equipment and artwork, including these amazing drawing machines. But I'm here because I'm working with a bunch of cool folks on an awesome project supported by the Heritage Lottery Fund, who we're very thankful to. If you're interested in synthesizers, likelihood is you already know what this is, because it's a pretty legendary piece of equipment from the 1970s, built by EMS Electronic Music Studios. And in fact, they had a factory building synthesizers in my hometown of Bournemouth, in Johns Road, which is my second name, which is a funny little coincidence. You can see it's partially deconstructed. We've taken the oscilloscope out, that's on the table over here, and I'm having a look behind the panels, checking various things are working. Have a little look inside here. Because this is all in aid of a project of restoring this absolute beast of a synthesizer. So, a basic overview of this incredible machine. You have over here a load of filters. You've got low pass and high pass. You've got envelope shapers. You've got ring modulators. You've got reverberation spring tanks. You've got a massive pin matrix patch bay. You can see the inputs and outputs. This is the audio signals, and then over here we have another whole one underneath this bunch of schematics here, which is the control voltage signals. So you've got a mixer kind of section with joysticks and all sorts of stuff. A sequencer, very interesting sequencer, utilizing ideas from very early computers, a digital sequencer, and you've got some meters up here, some nice Nixie tube displays there. You've got a keyboard here. We have a double keyboard, which is almost actually probably rarer than this whole section over here. What else have we got? The oscillators. 12 oscillators overall. We've got different types with ramp and triangle and square and low frequency. And we've got noise generators, random control generators, octave filter bank, lots. There's enough. There's enough. Yeah, a frequency counter even with nice Nixie tubes in there. Look at those. Quite a thing. The idea of my visit is to evaluate this thing and see what is actually broken. I am not going to be able to fix it today, but if we can break it down into the individual things, that's how you tackle a big task like this, just tackling one little bit at a time. And I tell you, just figuring out what's broken, what's working is a big enough job for today. The story of this thing's history is quite bonkers, the amount of people's hands that it's been passed through, and the amount of attempts to get it back to fighting fitness. At one point, it had been thrown out of its home in a university and was literally cut in half in a skip before it was saved by one of the professors. And from there, it's had quite a journey to get to this point, where we're optimistic now that we can cross the finishing line and have this absolute beast working. Going on the internet, there seems to be many different opinions on how many of these there are currently working. Kind of ranges from like 4 to 20 or something. I'm not entirely sure. All of them though, I believe, except maybe one, is in a private collection. So none of them are available for people to play and experience. But the cool thing with this is the guys who have it, it's their ambition to have this as a open to the community, which is what, you know, I love, being from the museum, where that's our whole ethos, is that things shouldn't be, you know, locked in a glass case or a crate in the warehouse at the end of Indiana Jones. They should be out being used, working, and adding to the legacy of these things and the people who made them. I would be lying if I said that this isn't a daunting task to try and fix this thing. It's been passed through many hands, as I said, and a lot of people have done a lot of good work to get it to this stage. I'm quite honoured that the guys have reached out to me to try and get it across the finishing line. I'll give you a quick look in the back here. You can see there's a load of wiring, quite a bit of wiring from these things, and at various points, as I said, this has been cut in half, so a lot of stuff has been kind of replaced, and you know, these pots are new, but the real heart of the machine goes through all of these wires which are currently unconnected, and yeah, it's quite a thing to get your head around where all these wires are going to, because there are so many of them. But the heart of the synthesizer are in these boxes, and these are the printed circuit boards. These cards in here, this is the real EMS Synthi 100. That, it looks cool, but that's basically just a glorified controller with all the knobs on. This is the real heart of it. All of these cards are in here. So I'm going to be moving on to testing all of these individually, seeing what's working, what's not working, and going from there. Wish me luck, eh? Luckily, a lot of these circuits will be fairly familiar to a lot of you who have worked on this era of synthesizer. You've got a lot of op amps, transistors and things. Not a great deal of things that are especially rare. There are a few quirks and things, but I am optimistic that this can be rejuvenated, just like a lot of the other synthesizers that we've worked on at the museum. The most daunting thing is the scale of it, but you know, we're not averse to a challenge, are we? So there are quite a few circuits to get this whole thing working, and split across 4 Euro card cases at the moment, which will go into the rack slots on the back, and then all of the wiring from all of the panel controls and the pins goes to the back of these card slots. So you got the white handled cards here, got blue handled cards, you've got the greens and the yellows. And you can see here you got the module locations in the card frames. You got the yellow handles and green handles. This is all the slots here. It tells you what all of them are, and also their diagram number, so you can find all of the schematics which are all in here. Oh, And for each one, you see this is the ring modulator. You've got an actual schematic and then a drawing of the card itself. You can zoom in and find where all of the components are. And here is a look at one of the cards. Pretty cool looking. You see on the back here, it slots into the connector down there. You can take it out and test it quite easily. It's quite a good way to make this all modular. There's also some extra little cards like here. This is the driver and decoder for these lovely Nixie tubes in there. This is only meant to be just a little cursory look at the thing, but let's have a little look under the hood here. This is what the underneath of the patch bay looks like. Loads of wires. And I believe these are actually new old stock replacements for the original. Looks more like that. Huh. These are a bunch of original parts that came out of it and I think suffered when it was cut in half. Breaks your heart to see it. And the detailed breakdown of whose hands this has passed through and the work that's gone on at various stages is well worth a longer video, so we'll save that. Well, I think you can appreciate with this amount of circuitry, there is fair potential for things to not be working. And so, I mean, I remain undaunted, but I think you can agree, right? It's a fairly ambitious project, but one that will be well worth it when we get this thing working. Okay, so I'm going to take you through the process now of how I'm testing these individual cards from the Synthi 100, and I have to take my hat off to the people who've gone before me and collected this really useful documentation. It's very handy. This card in particular is the Octave filter bank. If we go over here, you can see the controls here on the panel for the Octave filter bank. Basically, it's a set of fixed filters and you can mix each one individually in to your heart's content. And so we can see on this diagram here, this is showing us the layout on the card as viewed from behind. You can see all the traces there etched on the card, and on here it will tell you for instance that this particular op amp is A12, and we can find that on the card. That'll be this one here, and then you can look on the schematic here and find A12 there, and it will tell you which pins go off to which points in the circuit. So you can see what everything is and where you need to probe at, where you want to listen into the circuit and stuff. Each of these boards has a plated bit on the edge which slots into these edge connectors down here, and the back of the card frame here is already wired up to distribute the power, and the power funnily enough does differ on different pins on different cards, so it's really handy to be able to just hook up the power supply to the card frame, and that distributes it all to the different pins on each card. And I can go through and just plug the card and this extendo card in, and we can get the power distributed to, I don't have to reassign it to pins on individual cards. And this extendo card here is really handy because I can have the main card out from the frame and I can probe wherever I need to on the circuit. So with the Octave filter bank, we're going to put one signal input into it, and then it's going to break it into several filtered frequencies, which then come through, and then via the knobs on the panel over there, get mixed together to an output. But of course, one of the main problems with why this isn't working in the first place is because all of the panel controls, all of these patch bays are not wired across to the back of these card holders. So what I'm going to do instead is probe onto certain points of the circuit, and we can listen before and after where these potentiometers would normally be in the circuit, and get a pretty good idea of the state of this card. Okay, so I've got a signal coming in from my little Eurorack oscillator, and we know from the diagram here that if we listen to pin 6 on the right op amps, we are going to hear the output from these fixed filters. So let's find pin 6 on these and have a listen. Aha! And so I've got a pretty good idea that that card is in the vast majority working. And so this is the process that I'm going to have to go through for all of the rest of the cards. It does take a while because I've got to not only find the right points on the circuit, but actually understand what's going on in the circuit as well, and circumvent the fact that it's going to be difficult to hook it up to all of the panel controls. So I might have to put some resistors in certain places to kind of simulate the knobs that would normally be connected into the circuit off the pins on the back of the card holder. So yeah, wish me luck. And these synthesizer kind of circuits, the pure kind of, you know, oscillators and filters and the normal stuff that you would see on a old school synth like this, not actually the most complicated thing. The most complicated thing is once we get to the sequencer. And this is one of the coolest things about this synthesizer, especially at the time it was made. So this is a 256 step event memory organizer thing, and it's quite cool, and it's got many layers to it, many different features and things, and correspondingly it's quite big and complicated, and a lot of the things in here rely on each other to function, so it's a bit harder to test in isolation. But I am reassured because, you know, looking at the circuits of this, anyone who is familiar with kind of 4000 series logic chips, which a lot of people are in, you know, synth DIY circles, it will start to seem very familiar to you, I think. And it's very interesting to dive into this because it really gives an insight into the way that Peter Zinoviev and the guys at EMS came at this and the design ethos. They had an idea. They weren't a big, massive company that was going to be manufacturing custom integrated circuits and stuff. They just built this computer, basically, out of, you know, logic chips, and just got it done. And it's impressive, and it's cool. Again, multiple hats off to all of those people.
That's not a synthesizer, is it?
It's the keyboard. Right now we have card P in the test rig. This is the random voltage generator, and what I've done to simulate the pots on the panel is just use some resistors and handily on the test card. There are some points where I can connect those across, and so I've got my Eurorack here, which the voltage coming out is controlling the pitch of the oscillator. If we turn up the amp, you can hear it's working. And then if I remove this resistor, it's like turning the knob, so the speed will go faster. Cool. I don't know when there's going to be another update on this project. It's not just as simple as me just fixing it, which is not simple anyway, but I am just part of a team of people making this happen, and there are many other elements to the project than just plain fixing it. It's a community project, so there are loads of opportunities for engagement and things that need to be done properly, and we're not going to rush it. It's going to be done properly. So you will hear about this when it's ready, and it's going to be really cool when it happens.